We talked about numbers the other day, and it turns out that the mathematical establishment, they don't know what a number is. They haven't been able to define the word number. They don't know what a number is. Here you have two examples. I covered them the other day real quick here. Like Merriam-Webster says, number, a word, symbol, letter, or combination of symbols representing what? A number. Absolutely love that definition. What is a number? A thing that represents a number. Okay, now you know. And yeah, they confuse number with numeral. Numeral is what is the definition of that, the symbol that you use to replace or to represent a number. Okay, numeral is not number, two different things. Okay, and then you have the Wikipedia says a number is a what? Mathematical object. Mathematical object, yeah. What is it used for? To count or to measure? I really don't know. What are they referring to? Is that like a hammer? What do they use to measure? Or count? Hammer? So yeah, we don't know what a mathematical object is. We covered that the other day, so you can look that up. Okay. So yeah, we have no idea what a number is because it's not properly defined. Okay, and when we look at mathematical object, I went over that the other day. You just get more and more runaround. That's all you get. Okay. Okay, so here we synthesize and say, what is a number? Well, according to the establishment, it's a noun. Okay, and they equate it with a numeral, with a mathematical object. Those are all nouns. And we're saying no, number is a verb. Okay? It's counting. It's a verb to count. That's what number means. Okay, you can count to infinity. That's where the word infinite came from. Okay, that means you can count forever. You never stop. Nobody's ever done that. Nobody's gone to infinity and back. Unless you went to heaven. God maybe has counted to infinity. I don't know. And so under the universal movie, we consider it a dynamic concept. So we put it at the bottom, and here it is. Number is at the bottom, not at the top. What are we talking about here? Well, we're saying that at the top you have the static concepts. Okay, like object, distance, location, existence. No motion involved. You can synthesize that in a single frame of the universal movie. For the dynamic concepts, the ones at the bottom, you need at least two frames of the movie. Okay, what is this? Means that you need at least two locations. Okay, motion is two locations or more. And a number is counting, so obviously that's a verb, and therefore it requires at least two frames of the universal movie. So number is a dynamic concept. Now, a lot of people, or a couple of people, had problems with that, with defining number as counting and defining it as a dynamic concept. Here's one of them. He says the following. He says, a number is a word and a symbol representing a count, an arithmetic value used for representing the quantity. Okay. And again, when you talk about representing a count, you're confusing number with numeral. Okay, a numeral is that. Okay, so that's the issue. Number is the other words that you had there: count, quantity, amount, value. That's what number is. Number is counting. Okay, you're just putting a symbol like the number 5. Okay. That's the numeral, and that's just the symbol, and you're representing what? You're representing counting. And so, it's count and quantity, which is number. The representation is numeral. Okay, okay, let's remove this one here, and we'll go with the next one. The fellow says, same fellow, I think, says, one of the most important numbers is the number pi found all through nature. And pi is 3.14. Okay, it's just a relation between circumference and diameter. But what's the problem there? You can't count to 314. You can only count to whole numbers, in other words, to integers. You can go 3, 4, 5, 6. You can't go 3 1/4, 3 5/5, or whatever, or 4/5 or whatever. You cannot count to fractions, to decimals. Okay, you can only count whole numbers, integers. And you can't count to 0. So again, counting is what number is, and you can't count to 314. You can't count to fractions or decimals. which is simply a different form of representing a fraction. Okay, so fellow says, measuring is counting number of consistent length segments. Absolutely not. Okay, you can't count half a segment. Okay, you can only, if you're going to count segments, and that eliminates any fraction or decimal. Okay, so no, you can't count to less than one, increments of less than one. Okay, so here we have another fellow. He says the following. He says, technically, things like 1024 wouldn't be a number then. Why? He says, having those symbols next to each other is like period in decimals and slash in fraction. In other words, he's saying you have these symbols, 1, 0, 2, and 4, one next to each other, right? And they represent different things, he says. He says, each spot represents operations of future counting. Okay, and so he specifies there, he says, in 1024, the first tells you how many thousands to count. The second, how many hundreds, and so forth. Okay, tens and units. However, each time 1,000 or 100 is another operation to be done. And again, he doesn't understand what we're saying here. Numeral represents the number, and number is to count. So the numeral is a symbol that we use to represent to count. Okay, 1024 is a single numeral, the whole thing. Okay, you don't chop it up and say, oh, the ones over here represents thousands. We don't care about that. Okay, there's a single numeral there. Okay, and here I'll give you an example. Here you have the same number in Roman numerals. Okay. And for those of you who understand Roman numerals, there you have the M, the double X's, C, IV, etc. And those are Roman numerals. And you can say, well, the M represents 1,000, but see, you have two X's there. And each X represents 10. And if I wanted to represent 30, I would put 3 X's. And so now it's not positioned properly as it is in today's nomenclature. But I do an even better deal than that. There's the E with a cursive E, right? With an accent mark, and that's my version of 1024. Okay, so that's my 1024. There's no positions, no calculation, no operations to be done there. And there's the Klingon's version, a squiggly line there. Okay, that's his version of 1024. Okay. So again, you're confusing the issue here. You're thinking it's an operation that you got to count. No, you don't have to do anything. What we're saying is we're defining the word number, and we're saying number is simply to count. You count it up to there, whether you did or not. That's what the symbol represents. It represents a number that you counted to. Okay, it's a value, an amount. I don't know. I don't think there's a single human being ever that ever counted to 1,000,000. Okay? Listen to that again. Not a single human being has ever counted to 1,000,000, taken the trouble to count 1, 2, 3, 4, 5, 1,000, 1,001, 1,002, 100,001, 100,002. No one has ever done that. I'm almost sure. Unless he took a bet, hey, I'm going to count to 1,000,000. Why would anyone do that? So when we see 1,000,000, did you count to 1,000,000? No, that's just a symbol that represents, one with 6 zeros, represents the value, the counting up to 1,000,000. That's all it means. So we're talking about the meaning of it. So 1024 represents counting. It doesn't mean that you have to do, I have to do some kind of operation where I have to count to 1,000 to 100, and I'm going to put the thousands here and the hundreds here. No, forget about all that. It's a single value, a single numeral called 1024. We use 4 symbols there to make one numeral irrelevant. Okay, like I'm saying, the Klingon only uses a single squiggly symbol there, and he represents 1024 with that squiggly symbol. Okay, so no operation needed. What we're talking about is the definition of number. What does the word number mean? It means it's a verb to count. Okay, so let's get that right. And so the fellow continues. He says, I think it's the same fellow. He says, is it that you can or you have counted them? What about counting 10 to the 10 to the 10 to the 10? Can't do it. Is it not a number then? Yeah, again, it's we're talking about the definition, and this individual did not understand that. We're talking about the definition of number. What does the word number represent? What do we mean when we say number? And it's the verb to count. And here's an illustration of that. I showed that the other day. Let's show it one more time. This is count. Okay, it's how many times you move your finger. Okay, so we say numbers to count. And what are numbers? Many numbers. Naming each shake of the hand. So you say this is 1, this is 2 because it follows the other one, this is 3, this is 4, this is 5. We represent those symbols, we have a name for them, we say this is 5, this is 6, those are the words we use. Okay, what are we doing? We're counting. That's what we're doing. Does it mean you had to count? No, we don't do that anymore. We don't have to do that. We can say a million without counting to a million, and we use a symbol that is a 1 with 6 zeros to represent it. Okay, that's a story. Okay, now that leads us to what a number line is, because just now I showed you that you had many numbers there. You 1, 2, 3. When you have more than one, well, now you have a number line. Okay, and people say, what does a number line look like? What is it? And here's Bill Gaede's number line. Okay, you can take this one to the bank. Okay. This is Bill Gaede's number line. Here it is. Take a snapshot of it. It's going to come and go. Okay, there's Bill Gaede's number line. And a lot of people don't like it. They say, Bill, I don't like your number line because it's kind of messy. Well, you go from 1 to 2, then from the 2 to the 3, 3 to the 4, 4 to the 5, to the 6, around the corner to the of the 8 to the 7, then to the 8, then down to the 9. It's a number line. It's not a very straight line, but that's my number line, going from 1 to 9. Okay. Yeah, people don't like that and say, Bill, I think I can do better. Okay. And what do? Well, they have this instead. They say, this is the number line. See how neat it is? Everything is spaced out properly. We have a number underneath each one, etc. This is the official, the super duper number line. Okay. That's a number line. Okay. And yeah, we have a problem here because this is quite misleading. It's misleading because it's straight. It looks like a line, the typical line. And what's not shown here is that it also has direction. Okay. And all that is misleading. Okay. That's where the problem starts, when you think that that is a number line. And you represent it with this line with a little sticks, a little arrow at the end, you say that's a number line. No, it is, yeah, it's a number line in a sense, but it's very misleading, and I'm going to go over what is misleading about it, okay? Here's look up a definition, and this site, official site, instead of defining a number line, says it helps students visualize number sequences and illustrate strategies for counting, comparing, adding, subtracting, etc., right? Choose number lines labeled with whole numbers, fractions, decimal, so they include everything in there, negative numbers, or use custom number line with or without tick marks and set your own interval. So they have all these variations where some of them don't have tick marks, some of them don't have the proper interval, some might have exponential tick marks and so on. They're not the same as the typical Cartesian coordinates, right? So you have all kinds of variations on the number line. We have a problem with what these people are proposing, and let me tell you why. Here it is. Here's the number line, the official version. You'll find it in the Wikipedia, and I'm saying official because anywhere else you'll find more or less the same definition. Number line in elementary mathematics, really arithmetic, right? A number line is a picture of a graduated straight line that serves as visual representation of what? The real numbers. Every point of a number line is assumed to correspond to a what? Real number. And every real number to a point. And it talks about it continuing forever in each direction. And you can see the arrow there for direction. And those numbers, integers in this case, they call them points, okay? And you see also negative numbers, okay? You have also the zero in there. And the question whether all of that, if any of that makes sense. Here's first what the real number is. Okay, here's a real number. Definition says real numbers include rational numbers like positive and negative integers, fractions, and irrational numbers. In other words, any number that we can think of except complex numbers is a real number. For example, 3, 0, 1.5, 3 and a half, 3 halves, square root of 5, and so on. Okay, those are all real numbers. So they include everything in the number line. Number line includes all real numbers. The problem here, the first problem, is that math has no use for objects such as point and line. They're object, why? Because they have shape. In this case, they're two-dimensional. Essentially, that's what they're illustrating. You know, you could think of it as a 3D point, 3D line, no problem, but they're at least 2D, okay? And the point, you know, it doesn't belong to math at all. What are you going to do? Add points? Subtract lines? What are we going to do with this nonsense? Okay, so the point and the line does not belong, neither one belongs to number line, mathematics. And then the other problems again is direction. And we're going to have another problem with a number line, which is orthogonality, which is, you know, perpendicularity. And so here we have the problem is that they take time, you know, the word time. And first of all, nobody's ever defined the word time. Okay, that's the first problem. But then they're going to say that they're going to illustrate it as a number line and call it a dimension. Okay, so this is where the problem is. Time in physics is operationally defined as what a clock reads. That's out of the Wikipedia. Okay, there you have a perfect scientific definition. What a clock reads. Okay, whatever that is, okay, minutes, seconds, I don't know what it reads. I thought I read the clock, not the clock reads anything. Okay, and it says the operational definition of time does not address what the fundamental nature of time is. Great, we don't know what time is, but they say it's what a clock reads. They have these contradictions, they chase their tails around. But there we have an example, and what you see at the bottom is time. Okay, and it's going towards the right. You see that it's a number line because it's got all these numbers in between. It's got the partitions, you know, little tick marks. So they illustrate it as a number line. Okay, so you can see that I think there's no doubt there. And here you have another version of that. This is known as space-time diagram. And again, they illustrate it this time upwards. Okay, and they illustrate time as a number line. Okay, so they call this, or they illustrate as a number line. And you see that it's got a couple problems. The one is it's orthogonal, it's perpendicular to the space number line, because that's also a number line. And it's got direction. Both of them have direction. They have these arrowheads on them pointing in a given direction. And that's where we have a problem, because number lines don't have either one of those two properties. They don't have orthogonality and they don't have direction. Okay, those are dimensions that have those. And so we have a problem here because time is illustrated as a number line. It's treated as a number line because they're going to put numbers there, right? And they're going to separate them by seconds, minutes, hours, whatever interval they select. But they're going to call it a dimension. Okay, you see where the problem is? They're going to call this a dimension. Is a dimension the same thing as a number line? And we're going to say no, not true. Okay, so here it is. We have two sources here. First, the Wikipedia, and I like these contradictions between these two sources. A temporal dimension or time dimension is a dimension of time. I thought it was a number line, not a dimension. Time is often referred to as the fourth dimension for this reason, but that is not to imply that it is a spatial dimension. What does Stevie Hawking say? He says, in relativity, there is no real distinction between the space and time coordinates. He doesn't even call them dimensions, he calls them coordinates, okay? Just as there is no real difference between any two space coordinates. I think that's clear. So we have a contradiction between what the Wikipedia says and what good old Stevie says. Okay, one guy says there's no difference. The other guy says, oh, don't confuse the time dimension with the spatial dimensions. Turns out neither one is a dimension. They're both number lines. And so the question again is for you to think is whether a number line is the same thing as a dimension. For instance, instead of measuring the position of a, well, he goes in there and just explains that there's no difference between these two. You can look that up later on from his book, famous book, A Brief History of Time. Okay, so here we have a problem with all these folks because we're saying, hey, you know, if time is illustrated as a number line, keep it as a number line. Don't tell me it's a dimension. And again, one of the problems these people have is they say that the universe is four-dimensional. If it's four-dimensional, it means it's got length, width, height, and who knows what else? No, they're saying it's four-number-lined. They have four number lines to locate any point within space-time. That's what they mean. It's the other way around. But they say space-time is four-dimensional because you need four coordinates to locate a point within space-time. That's the notion, the definition, or whatever. Okay, so here we have the difference between number line dimension for all those who care to take note. Number line belongs exclusively to math. It doesn't belong to physics at all. We don't use number lines in physics. Why? Because in physics we have to explain causes and mechanisms. Math is just a language, you know, and it's a language that uses numbers. And the number line, a series of numbers, it has no direction. As soon as they put that arrowhead, they're cheating because numbers have no direction. What they're trying to show you is that numbers increase, that's what they're counting. Remember, what is a number? A number is integers that you count. And they count them in a, you know, you can put them in any direction you want. You can count, I mean, the 2 doesn't follow physically in a given direction from 1. The 3 doesn't follow in a given direction from 2. They just say, look, we put them in a certain order so you know that numbers are increasing in that direction, but there is no direction to counting. And so the first problem is that there is no direction for number lines. The second problem, it's not orthogonal to anything. And here they put the time, especially in the space-time diagrams, they put time perpendicular to so-called space, where they put all 3 dimensions into one and they call that space, whatever that means, you know, physically. So they have the space number line, the time number line, and they put these perpendicular to each other. In what direction does time run? Forward, backward, to the sides? And does it run perpendicular to anything? Absolutely not. So number line, known as time, runs in no direction and is perpendicular to nothing. And that applies to all number lines. Okay? Number line, it's counting, numbers counting, so number line has many counts because you're talking about many numbers. It's a dynamic concept. Okay? There's no static part of it. Dimension, on the other hand, it's has direction, okay? Has perpendicularity, as you can see there. Height is perpendicular to width by definition, which is perpendicular to length by definition. All 3 of them are mutually perpendicular. Time does not fit in there because we cannot put time perpendicular to any dimension. Okay? Anyone who does that is dealing with dementia, not with dimensions. Has perpendicularity, orthogonality, yes. Perpendicular comes from perpendiculum. You do not need to know anything about angles for that. Okay? Here's this is the number line, bgaede's number line. You can see I was right. We have no direction there, no perpendicularity. Okay? But here, let me show you that what perpendicular means. It comes from this. It's from perpendiculum, and that was the plumb bob, which they used to usually for walls. They would look at the horizon and say, okay, the wall is more or less straight. You know, so you don't need to know really anything about angles to understand the concept of perpendicular. Okay, so that's all I'm trying to show here. Okay, let me get rid of this one. It's a qualitative concept. You don't need to know anything about numbers and no need to know about angles. again, numbers. Okay, qualitative angles, yeah, you could say this one is perpendicular, and anything between is half perpendicular or whatever. You don't really need to know numbers to conceptualize an angle. Okay. Now, if you want to tell someone, look, it's a 30-degree angle, yeah, then you're going to have to put a number in there. Okay. But then we don't need numbers to understand angles. It's just a qualitative, two sticks. That's all it is. Okay. Without knowing the language of someone else, here I'll take two pencils and do it. You can say, look, this is more or less what the angle was that I saw of whatever. And you don't even need to know much of the language or what the angle exactly was. You say it was more or less like that. And the guy understands, okay, I know what you're talking about. Neither one needs to know how many degrees that thing was turned over, which is what degrees are. It's how much you scan one stick with respect to another. No magnitudes involved, and it's a static concept. Dimension is a static concept. So yeah, these two are very different. One is dynamic, one is static. The other one has direction, the other one doesn't. And one has magnitude, the other one doesn't. One has perpendicularity, and the other one does not. Okay, so here we have good old Hawking, and he says, that's why he ends up saying the nonsense that he says in his book. He says, it is often helpful to think of the four, coordinates. Oh, coordinates. I thought it was a dimension, okay, or a number line or whatever, of an event as specifying its position in a four-dimensional space called space-time. It is impossible to imagine a four-dimensional space. Yeah, no kidding. But yeah, so he's saying that it's four-dimensional. No, or four coordinates. It's neither one. It's four number-lined. That's what they're talking about. They're not talking about dimensions or coordinates. What the problem is that they define a dimension as the number of coordinates. And what is a coordinate? A number, so it's the number of numbers. They're talking about number lines. They're not talking about dimensions. And so to say that the universe or space-time or whatever is four-dimensional, it's a lie. Okay, it's a lie from every point of view, from a definitional point of view and from a physics point of view. No such thing as four-dimensionality, no such thing as a universe that is four-dimensional. Okay? In fact, the universe is not even three-dimensional, because when they use the word universe, they're talking about space, and space has no dimensions whatsoever. Space is zero-dimensional because it's nothing. Only things have dimensions, and space is the opposite of thing. It's a nothing. Okay, and so here we have it. It's a static concept for, it's a dynamic concept for number line also. Okay, number and number line both are dynamic concepts. Okay, neither one is a static concept. Okay, so in the Universal movie, you need at least two frames of the movie to conceptualize a number line.